okay? So I'll make sure no one touches it.
Please find a seat. There's some seats up here in the front row if you'd like. Thank you very much. Welcome to our Aquinas lecture series. I'm going to ask Father Earl to begin us with a prayer.
In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Lord Jesus, you are the way, the truth, and the life. Send on us your spirit of truth, that our hearts may be open and to hear truth being spoken tonight. Open our minds, Lord, to pay due attention to the lecture that we're being presented tonight, and guide us in our appropriation of this. We thank you for this. In the Father, Son, and Holy Spirit.
Thank you, Father Earl. In order to continue the promotion of academic excellence at Notre Dame Seminary, the Aquinas Lecture Series was inaugurated in the spring of 2005. Given in the spring, the Aquinas Lecture Series invites a guest lecturer whose scholarly work has made an important contribution to the field of Thomistic theology or philosophy. From Pope Leo XIII's Aeterni Patris to St. John Paul II's Fides et Ratio, the Magisterium has singled out the teaching of St. Thomas as a sure guide. Leo VIII wrote of the angelic doctor, "With his spirit at once humble and swift, his memory ready and tenacious, his life spotless throughout, a lover of truth for its own sake, richly endowed with human and divine science. Like the sun, he heated the world with the warmth of his virtues and filled it with the splendor of his teaching." With regard to seminary formation, the Second Vatican Council was clear about the role that Thomas's thought should play. The decree on priestly training reads, "In order that they may illumine the mysteries of salvation as completely as possible, the students should learn to penetrate them more deeply with the help of speculation under the guidance of St. Thomas and to perceive their interconnections." At Notre Dame Seminary, the Aquinas Lecture provides an important venue for promoting the thought of Thomas Aquinas. Past speakers have included a who's who of Thomistic scholars, including Fathers Norris Clark, Benedict Ashley, Romana Cesario, and Lawrence Diwan. With our present speaker, we continue our tradition of bringing the finest scholars in Thomistic scholarship. For a bit of housekeeping for our guests, our restrooms are on my left in the hall in the back, and afterwards we're going to have a Q&A at the center microphone. The first person up needs to turn on the mic for me. I would now like to introduce our director of the Masters of Arts in Theological Studies program and professor of theology and historical theology, Dr. David Liberto.
Thank you. One other note in terms of housekeeping is after the lecture, we will take a full 5-minute break so you can use the restroom, stretch, and then we'll reconvene for the Q&A. It's my pleasure and privilege to introduce our speaker tonight. Professor Edward Feser is Associate Professor of Philosophy at Pasadena City College in Pasadena, California. He's been a visiting assistant professor at Loyola Marymount University in Los Angeles, and a visiting scholar at the Social Philosophy and Policy Center at Bowling Green State University in Bowling Green, Ohio. He holds a PhD in philosophy from the University of California at Santa Barbara, and an MA in religion from the Claremont Graduate School, and a BA in philosophy and religious studies from the California State University at Fullerton. Called by National Review one of the best contemporary writers on philosophy, Professor Feser is the author of several books, a few of which are the following: Philosophy of Mind, Locke, The Last Superstition, a refutation of the new atheism, which I've seen in several hands tonight, Neo-Scholastic Essays, and 5 Proofs of the Existence of God. His most recent effort, published just last year, is Aristotle's Revenge, The Metaphysical Foundations of Physical and Biological Science. He's also the author of many academic articles. He writes on politics and culture, and his many essays can be found in such publications as The American Conservative, Crisis Magazine, First Things, the New Oxford Review, and Public Discourse. Here to deliver this year's Aquinas lecture entitled, What is Matter? From Aristotle to Modern Physics and Back Again, please help me in welcoming Dr. Edward Feser.
Well, thank you all for coming tonight. So my topic is, as David just mentioned to you, is what is matter. I was thinking of giving it a jazzier title, like What's the Matter? And I realized that might attract a very different audience, maybe people coming expecting relationship advice or something like that. So I kept it dry and boring. My subtitle, I guess, requires a little bit of comment. The subtitle is, again, From Aristotle to Modern Physics and Back Again. And that, as many of you may know, is an homage to Etienne Gilson, who put out a book. It's one of his less well-known books, but it's called From Aristotle to Darwin and Back Again, where he tries to show a continuity between Aristotelian philosophy of biology, you might say, and modern biology. And so what I'm doing in this talk, and then what I do at greater length in my most recent book, Aristotle's Revenge, is to try to show something similar, but with respect to physics rather than biology. So that's the source of the title. So, nothing could be more familiar than material objects. Tables and chairs, rocks and trees, dogs and cats, and human bodies. But what exactly is matter? The history of philosophy and science shows surprisingly little consensus on how to answer that question. As Stephen Twillman notes in the article on matter in the Old Encyclopedia of Philosophy, quote, "It is highly doubtful whether one can isolate a single concept of matter shared by, say, Anaximander and Aquinas, Democritus and Descartes, Epicurus and Einstein," unquote. Yet the answer could hardly be more significant for the two fields. Some of the central problems of philosophy ride on it. Consider, for example, the ancient controversy over whether mind is reducible to matter. Materialists say that it is, dualists say that it is not. Obviously, you have to have some idea of what matter is before you can go on to judge that one or the other of these views is correct. Or consider physics, which is often described as more fundamental than the other sciences insofar as it studies not just this or that specific kind of material thing, but the building blocks of all matter. You first have to have at least some idea of what matter is in order for this characterization to be informative. In this talk, I'll be discussing what I take to be the 3 historically most influential and important accounts of the nature of matter. The first is the hylomorphism originally developed by Aristotle in response to the views of his predecessors from Thales to Plato, and later refined by Thomas Aquinas and other scholastic thinkers. The second is what you might call the mechanical philosophy that the founders of early modern philosophy and science put in place of hylomorphism. And the third is the account of matter offered by quantum mechanics. I will not only defend hylomorphism, but will argue that its rival, the mechanical philosophy, is plagued by insuperable problems, and that quantum mechanics is not only compatible with hylomorphism, but if anything, vindicates it, or at least less ambitiously, at least gestures back in the direction of Aristotle. So if you have the handout, which was given out at the door, we'll turn to section 2 here, where I want to lay out a little bit of background to Aristotle's development of hylomorphism. Hylomorphism occupies the middle ground between two extremes that had developed in pre-Socratic philosophy: the dynamic monism of Heraclitus and the static monism of Parmenides and Zeno. Heraclitus denied the permanence and unity of everyday objects. To illustrate his thesis, I'll borrow an example from physicist Richard Feynman, who gives the following lucid description of the evaporation of a glass of water in the famous Feynman lectures on physics. I'm going to quote from Feynman here at length because I find the passage very useful by way of illustration. At the very least, you can just sort of close your eyes and pretend you're listening to a Richard Feynman lecture, if you prefer that to one of mine. So, quoting from Feynman, quote, "Above the surface, we find water vapor, which is always found above liquid water. In addition, we find some other molecules. Here, two oxygen atoms stuck together by themselves, forming an oxygen molecule. There, two nitrogen atoms also stuck together to make a nitrogen molecule. Air consists almost entirely of nitrogen, oxygen, some water vapor, and lesser amounts of carbon dioxide, argon, and other things. So above the water surface is the air, a gas, containing some water vapor. Now, the molecules in the water are always jiggling around. From time to time, one on the surface happens to be hit a little harder than usual and gets knocked away. Thus, molecule by molecule, the water disappears, it evaporates. But if we close the vessel above, after a while, we'll find a large number of molecules of water amongst the air molecules. From time to time, one of these vapor molecules comes flying down to the water and gets stuck again. So we see that what looks like a dead, uninteresting thing, a glass of water with a cover, that's been sitting there for perhaps 20 years, really contains a dynamic and interesting phenomenon which is going on all the time. To our eyes, our crude eyes, nothing is changing. But if we could see it a billion times magnified, we would see that from its own point of view, it is always changing. Molecules are leaving the surface, molecules are coming back. Not only does the water go into the air, but also from time to time, one of the oxygen or nitrogen molecules will come in and get lost in the mass of water molecules and work its way into the water. Thus, the air dissolves in the water. Oxygen and nitrogen molecules will work their way into the water, and the water will contain air. Okay, unquote. So that's a long quote from Richard Feynman. Now, though the terms of this description are modern, I think that Heraclitus would interpret it as a fine illustration of his basic claim. So that's not Feynman's purpose, I hasten to add. But I think Heraclitus would probably take it as support for his own claims. Common sense would regard the water in the glass as a single unified substance that persists over time and can be sharply distinguished from what surrounds it. But in fact, Heraclitus would say, it is an aggregate of constantly changing parts that persists no longer than any particular configuration of the parts does, and the boundaries of which blur into those of its surroundings. As Heraclitus famously put it, you can never step in the same river twice, because the water is constantly changing, and so the river is constantly changing. Indeed, for Heraclitus, the only genuinely abiding substance is the world as a whole, of which the ordinary objects of our experience are merely the ever-shifting appearances. To be sure, again, I'm not saying that Feynman's description actually vindicates Heraclitus' dynamic monism, but that was certainly not what Feynman himself was trying to do. In fact, the scientific evidence can be given an alternative philosophical interpretation, as we'll see. In fact, several alternative philosophical interpretations. In any event, if such empirical considerations might at least seem to offer support to Heraclitus, Parmenides and Zeno notoriously appeal instead to abstract rational arguments in support of their contention that it is change and multiplicity, rather than permanence and unity, which are illusory. Take Parmenides first. He argued that for change to occur would require non-being to give rise to being. For example, when the water in the glass cools, the coolness has to go from non-being to being. But for being to arise from non-being is for something to come from nothing, and from nothing comes nothing. Therefore, Parmenides concludes change is impossible. But so too is multiplicity. For two or more things to be distinct objects, there would have to be something that sets them apart. In Parmenides' view, this would be the empty space between them. Now, empty space, he claims, would be the absence of anything, or non-being. But precisely because it is the absence of anything, non-being does not exist. In that case, empty space does not exist, so that there's nothing that can set apart purportedly different things. So there really are no different things, but just one thing, being undifferentiated and unchanging. So Parmenides' view famously is that what exists is being, and if you say, what's it doing, Parmenides? It's being. Being is being, that's all you can say. What is. Now, Zeno famously defends Parmenides' teaching with a set of ingenious paradoxes, of which we'll consider two. In his dichotomy paradox, Zeno asks us to consider a runner trying to get from point A to point B. Common sense supposes that nothing could be easier, but Zeno holds that on analysis, the journey can be seen to be impossible. For in order to get from A to B, the runner first has to get from A to the midpoint between A and B. But to get to the midpoint, he first has to get to the quarter point. To get to that, he first has to get to the eighth point, and so on ad infinitum. So he can never reach B, and indeed cannot even get his foot off of point A, since even to move an inch would require traversing an infinite series of ever smaller distances. This sort of paradox shows, in Zeno's view, that motion is an illusion. So if you're already bored by the lecture, I'm sorry, you're not getting out of here. It's like Hotel California, you can check out, but you can never leave. You have to get 1 foot out the door, you have to first get half a foot out the door. All right, then we have Zeno's paradox of parts, which begins with the thesis that if there really were multiple objects in the world, then either they would have size or they would have no size. Now, if they have no size, then nothing has any size, because combining any number of things with no size can only ever yield something with no size. Hence, everything would be the same size, namely no size at all, zero size. But of course, that's absurd. But supposing that there are multiple things that do have size also leads to absurdity. For if they do have size, then they are divisible into parts of smaller size, and those of yet smaller parts, and so on ad infinitum. But then they each have an infinite number of parts, and since the thing is bigger, the more parts that are added to it, it would follow that they are infinite in size. Hence, everything would be of the same size, namely of infinite size. But this too is absurd. So either way, the assumption that there are multiple objects leads to absurdity and must be rejected. Imagine if Zeno ran a McDonald's, like Zeno's, right? You have two options, the zero size option and the infinite size option. If you're on a diet, you're out of luck. Now, Aristotle's hylomorphism is grounded in a crucial distinction that he develops when explaining where Heraclitus' dynamic monism and Parmenides and Zeno's static monism go wrong. Their mistake in Aristotle's view is failing to note the difference between actuality and potentiality, or act and potency, as us unreconstructed Thomists prefer to call it. So consider an ice cube. In describing it, we might note that it is solid, transparent, a cubic inch in size, cold to the touch, sitting motionless on the table, and so on. Those are the different ways that it actually is. But that would not be a full description, which would require noting also the ways it potentially could be. For example, potentially it is liquid if you melt it. Potentially it is flying through the air if you throw it. Potentially it is smaller if you break a piece off of it, and so on. A potentiality is not an actuality, but it's not nothing either. It is really there in the ice cube, even if not actualized. For example, if you keep an ice cube in a freezer for 10 years and it never in fact melts, it still has the potential to melt in a way that it does not have the potential to turn into gasoline or to grow legs or to solve equations. Aristotle would say that while Parmenides is correct to hold that being cannot arise from non-being, his error is to suppose that that is what change would involve. What change really does involve is one kind of being or reality coming from another kind. Being in actuality arising from being in potentiality. Or to speak a little more plainly, change involves the actualization of a potential. It is also wrong for Parmenides to characterize the space between objects as nothingness or non-being, because it has potentialities, and potentialities are not nothing. Potentiality to receive objects coming into it, for example. Once we identify potentiality as a kind of reality distinct from actuality, Parmenides' arguments against change and multiplicity collapse. Now, Zeno makes a similar error in Aristotle's view. While it is true that there's an infinite number of ever smaller distances between points A and B, these smaller distances are there only potentially rather than actually. Hence, there is not an actual infinite number of distances for a runner to traverse, and the dichotomy paradox falls apart. Similarly, the infinite number of parts in an object are there only potentially until we do something to divide it. Until we divide it, there is in actuality just the one object. Hence, the paradoxical consequences of an object having an actually infinite number of parts are also blocked. Now, the error of Parmenides and Zeno is essentially to collapse all of reality into actuality, ignoring potentiality. Heraclitus makes the opposite error of essentially collapsing all reality into potentiality and denying actuality. For he holds that there is only endless becoming, change that is not changed to anything, that never congeals into anything determinate. In effect, he posits a world of potentialities which only ever give way to other potentialities without any of them being actualized. But this cannot be. For potentialities, though distinct from actualities, are grounded in actualities. For example, it is because the ice actually has the chemical structure that it does that it has the potentiality to melt when the temperature drops below 32 degrees Fahrenheit. If it had some other structure, it would have a different melting point. Okay, so much by way then of the background to hylomorphism. So to turn to section 3 now and address hylomorphism itself, beginning with what I refer to here on the handout as the real distinction of matter and form. So we'll come back to some of these issues that I've been describing here, but for the moment, let's see at last how all of this gives rise to hylomorphism. As scholastic followers of Aristotle like Thomas Aquinas point out, the distinction between actuality and potentiality is completely general, applying to all possible kinds of substance. For example, suppose there are angelic intellects, which would be minds that exist apart from matter. They would go from potentiality to actuality when created by God. But the notions of potentiality and actuality apply in a special way to physical things, the objects of perceptual experience. Unlike angelic intellects, physical objects are susceptible of both generation and corruption, and they occupy specific locations in space and time. What makes this possible is that they are composites of potentiality and actuality of special kinds, namely matter and form, where the Greek words for matter and form, boule and morphe, give us the word hylomorphism. In change, there is again both potential that is to be actualized and the actualization of that potential. Consider the ink in a dry erase marker. While still in the pen, it is actually liquid, but it has the potential to dry into a triangular shape on the surface of a marker board. When you use the pen to draw a triangle on the board, that potential is actualized. Having dried into that shape, the ink has yet other potentials, such as the potential to be removed from the board by an eraser, and in the process to take on the form of dust particles. When you erase the triangle and the dried particles of ink fall from the board and or get stuck in the eraser, those potentials are actualized. Now, what we have in this scenario is, first of all, a determinable substratum that underlies the potentialities in question, namely the ink. It's determinable in the sense that it could be a this or that, but so far considered by itself. It's not any one of those things in particular. It's not yet determined, but it's determinable. We also have a series of determining patterns that substratum takes on as the various potentials are actualized. Patterns like being liquid, being dry, being triangular, and being particle-like. The determinable substratum of potentiality is what in hylomorphism is meant by the term matter. And a determining pattern that exists once the potential is actualized is what is meant by a form. Matter is essentially that which needs actualizing in change. And form is essentially that which results from the actualization. Note that any determining actualizing pattern counts as a form in this sense. A form is not merely the shape of a thing, nor is it necessarily a spatial configuration of parts, though shape and spatial configuration are kinds of forms. Being blue, being hot, being soft, etc. are also forms in the relevant sense. Okay, so that's one argument in brief for hylomorphism. It's sometimes called in the literature the argument for change, for the reality of form and matter. But change is not the only phenomenon that points to the distinction between matter and form. There's also what's called the argument from limitation, so let me say a little bit about that. Note that a form or pattern like triangularity is universal rather than particular. It is the same pattern that one finds in green triangles and red ones, triangles drawn in ink and those drawn in pencil, triangles used as dinner bells and those used on a billiards table, and so forth. Triangularity is also perfect or exact rather than approximate. Triangularity is defined by the geometers, say, is perfect or exact triangularity rather than merely an approximation. For example, being triangular in the strict sense involves having sides that are straight rather than wavy. Now, the triangle you draw on the marker board has straight sides, but only imperfectly or approximately. It is also a particular instance of triangularity rather than triangularity as such, rather than triangularity as a universal. Hence, there must not only be something by virtue of which the thing you've drawn is triangular, but also something by virtue of which it is triangular in precisely the imperfect way that it is. There must also be something by virtue of which triangularity exists at this particular point in time and this particular point in space, given that triangularity as such is universal. Now, if being triangular is a way of being actual, being triangular only in an imperfect way is a way of being potential. For insofar as the triangle's sides are only imperfectly straight, the ink in which you've drawn it has, you might say, only partially actualized the potential for triangularity. And insofar as the triangle has been drawn in some particular time and place, the potential in question is a potential at that time and place, rather than at another, that has been actualized. Now, that by virtue of which what you've drawn is actually triangular to the extent that it is its form, while that by virtue of which it is limited or remains merely potential in the extent to which it is triangular is its matter. Okay, so that's the argument from limitation, the idea being that a form by itself is universal. So we need some principle that accounts for how it gets tied down to a particular time and place. That's what matter does. Or a form by itself is perfect. So we need a principle in addition to the form to account for how it gets the imperfections it does in a particular instance. That's what matter does. So matter limits form in both those ways, to a particular time and place, an individual, and in the degree of perfection that that individual exhibits. Okay. So insofar as form accounts for whatever permanence, unity, and actuality there is in the natural world, it represents, as it were, the Parmenidean side of things. The triangle drawn on the marker board persists to the extent that it retains its triangular form. It is identical to other triangles, it has a kind of unity with them, insofar as it is an instance of the same one form that they instantiate, and is perfect or complete in its actuality to the degree that it approximates that form. So form does a Parmenides type job, you might say. It accounts for the stability there is in the world, the sort of perfection there is in the world, and so forth. Insofar as matter accounts for the changeability, diversity, potentiality that exists in the world, it represents instead the Heraclitean side of things. The triangle drawn on the board is impermanent insofar as its matter can lose its triangular form. It is distinct from other things having the same form insofar as it is merely one parcel of matter among others which instantiate it, and is imperfect or potential to the extent that it merely approximates form. Okay, so again, matter plays that Heraclitean role of explaining the fact that things change and are unstable to the extent that they're multiple rather than unified, multiple material instances. The universal pattern that they instantiate, and so forth. Now, matter is passive and indeterminate, form is active and determining. The same bit of matter can take on different forms, and the same form can be received in different bits of matter. Hence, matter and form are as distinct as potentiality and actuality are. Still, just as potentiality is grounded in actuality, so too does matter always have some form or other. If the ink in our example is not in liquid form, it is in a dry, triangular form. And if not that, then in the form of particles. And if the particles are broken down further so that the ink is in no sense still present, then the form of the chemical constituents of the ink would remain. If matter lacked all form, it would be nothing but the pure potentiality for receiving form. And if it were purely potential, there would be no actuality to ground it, and it would not exist at all. Now, several further distinctions are needed in order to flesh out the hylomorphic analysis of what it is to be a physical substance. So this brings us to point B under 3 here. And I know what you're thinking. You're thinking, I'd like to talk so far, but there's not enough technical jargon. I want more technical jargon, so I aim to please. So several further distinctions are needed, as I say, in order to flesh out the hylomorphic analysis of what it is to be a physical substance. And the first is this general distinction between any substance and its attributes. Or for its accidents, to use a more traditional term. So consider a solid, gray, round, smooth stone of the sort that you might pluck from a riverbed. The solidity, grayness, roundness, and smoothness are attributes of the stone, and the stone itself is the substance which bears these attributes. The attributes exist in the stone, whereas the stone does not exist in any other thing in the same sense. Substances in general just are the sorts of things which exist in themselves rather than inhering in anything else, and which are the subjects of the attributes which do of their nature inhere in something else. This is true of physical or corporeal substances like stones, and it is true of incorporeal substances too, if there are any such things, which, as we all know, there are angels, but I had to throw that qualifier when I was speaking in Cornell. Okay. Let's take it all the way. Okay. So physical substances are again composed of form and matter, but here two further distinctions must be made. We abstract from our notion of matter all form, leaving nothing but what I've called the pure potentiality to receive form. We arrive at the idea of what's called prime matter, and I'll say more about this in a moment. Matter already having some form or other, that is to say, matter which is actually a stone, or wood, or water, or what have you, and is not merely potentially any of these things, is secondary matter. There's a corresponding distinction between kinds of form. A form which makes of what would otherwise be utterly indeterminate prime matter some determinate concrete thing of a certain kind is a substantial form. A form which merely modifies some secondary matter, and in particular which modifies matter which already has a substantial form, is an accidental form. Stated more precisely then, the basic claim of hylomorphism is that a physical substance is a composite of prime matter and substantial form. Okay. Now, there are a couple ways to think about the marks or indications of the presence of a substantial form. And just to keep things within a manageable time length, I'll focus on what I've got here, 4b, on the topic of irreducible properties and causal powers as a mark of a substantial form. Basic idea here is that it seems to be essential to a thing's having a substantial form that it has properties and causal powers that are irreducible to those of its parts. Hence, water has properties and causal powers that hydrogen and oxygen do not have, whereas the properties and causal powers of, say, an axe seem to amount to nothing over and above the sum of the properties and powers of the axe's wood and metal parts, to borrow an example from Eleanor Stump. When water is synthesized out of hydrogen and oxygen, what happens is that the prime matter underlying the hydrogen and oxygen loses the substantial forms of hydrogen and oxygen and takes on a new substantial form, namely that of water. By contrast, when an axe is made out of wood and metal, the matter underlying the wood and the matter underlying the metal do not lose their substantial forms. Rather, while maintaining their substantial forms, they take on a new accidental form, that of being an axe. There's a further complication in the story. Among the attributes of a thing, we need to distinguish those that are proper to it from those which are not. It is the former alone which are labeled properties in Aristotelian Thomistic philosophy, with the others referred to as contingent attributes or contingent accidents. This contrasts with a very loose way that the term property is used in contemporary analytic philosophy to refer to more or less any feature we might predicate of a thing. The properties or proper attributes of a substance are those which flow or follow from its having the substantial form that it does. They're sort of the byproduct of its nature or substantial form. Being four-legged, for example, flows or follows from having the substantial form of a dog. It is a natural concomitant of dogness as such, whereas being white, say, is not, but is merely a contingent attribute of any particular dog. You might say a fully mature and healthy specimen of a dog is going to have 4 legs. If the dog lacks 4 legs, that's because it's not a fully mature or healthy specimen, whereas a fully mature and healthy specimen of a dog may or may not be white and have some other color. So color is a merely contingent accident, whereas four-leggedness is a proper accident. Now, this flow of proper accidents from substantial form can, as it were, be blocked. For example, as I say, a particular dog might, as a result of injury or genetic defect, be missing a leg. But it wouldn't follow from its missing that leg that being four-legged is not, after all, a true property of dogs. Nor would it follow that this particular creature was not really a dog after all. Rather, it would be a damaged or defective instance of a dog. When determining the characteristic properties and causal powers of some kind of thing, we need to consider the paradigm case, what that kind of thing is like when it is in its mature and normal state. So a thing counts as a true substance when it has a substantial form rather than a merely accidental form, and the mark of its having the former is that in its mature and normal state it exhibits certain properties and causal powers that are irreducible to those of its parts. Aquinas' interpretation of hylomorphism insists on the doctrine of the unicity of substantial form, according to which a substance has only a single substantial form. So suppose A is a substance that has B and C as its parts. Maybe A is water, that's our substance, and then hydrogen and oxygen are the parts of the water. Take those to make the example a little more concrete. Now, since A, the water, is a substance, it must have a substantial form. So do B and C have further substantial forms of their own, these parts? Well, if they did, then they too would be substances. But in that case, A's form would relate to B and C as an accidental form relates to secondary matter. And then in that case, A, the water, wouldn't really have a substantial form after all, and thus it wouldn't really be a substance. And so if A, or water, really is a substance, then its parts, B and C, must not themselves have substantial forms or amount to true substances in their own right. There is only the single substantial form, the form of A, water as a whole, which informs the prime matter of A. Another way to look at it is that if B and C, again, the oxygen and hydrogen in our example, had substantial forms of their own, then they would be what actualizes the prime matter so that it constitutes a substance, or two substances in this case, namely B and C considered individually. In that case, the prime matter wouldn't potentially be a substance, but would already actually be a substance. That is to say, it would be secondary rather than prime matter. But then there would be nothing left for the substantial form of A, the substantial form of water, to do, qua actualizer of prime matter. It would serve merely to modify an already existing substance, or two already existing substances, and thus amount to an accidental form rather than a substantial form. And so again, a substance like A, water in our example, can really only have one substantial form. Now, to see the implications of this, consider once again our example of water, which has hydrogen and oxygen, as I say, as its parts. And so suppose, for the sake of argument, that water is a true substance rather than an aggregate, and thus has a substantial form. This is something actually Aristotelians argue about whether water is actually a substance or not, but put that aside for the moment, just suppose it is for the sake of argument. Since a substance can have only a single substantial form, it follows that the hydrogen and oxygen in water don't have substantial forms. That entails in turn that hydrogen and oxygen don't exist in water as substances. Now, this may seem odd, since hydrogen considered by itself and oxygen considered by itself each do seem to be substances. They have their own characteristic, irreducible properties and causal powers, after all. But the lesson we should draw from these considerations, according to the doctrine of the unicity of substantial form, is that hydrogen and oxygen do not exist actually in the water, but only virtually. Now, notice that the claim is not that they don't exist in the water at all, not contradicting modern chemistry here. It's rather that they don't exist in water in the way that they exist when they exist on their own. The situation is comparable to the Aristotelian account of what is really going on in Zeno's paradox of parts scenario, in which the parts are present, they're not nothing or non-being, but only potentially rather than actually. Remember, potentiality is it's not nothingness, it's real, it's just not actuality. This too may sound odd, but it should sound less so upon reflection. Consider that if hydrogen and oxygen were actually present in the water, just the same sense that they're present when you have them, by themselves and not forming a compound like water. If they were actually present in the water, then they should possess their characteristic properties and causal powers. That means that we should be able to burn the hydrogen, to boil the oxygen at minus 183 degrees Celsius, but we cannot do either. Hence, the substantial forms of hydrogen and oxygen cannot be present, in which case the substances, hydrogen and oxygen, cannot be present. Furthermore, if hydrogen and oxygen were actually present, then for something to be water would be for it to have a merely accidental form, and properties and causal powers that would be reducible to those of hydrogen and oxygen, which is considered as an aggregate stuck together. But that is also not the case, since water has properties and causal powers that a mere aggregate of hydrogen and oxygen does not have. Hydrogen and oxygen are present in the water then, but in the sense that water has the potentiality to have hydrogen and oxygen drawn out of it by electrolysis, say, the way you can draw other substances out of water. As I've indicated, two of the motivations for hylomorphism have to do with its application to the critique of Parmenides' static monism's denial of multiplicity and of change. These lines of argument for hylomorphism are, as I noted earlier, sometimes labeled the argument for limitation and the argument for change. The basic idea of the first line of argument is, again, that a form is of itself universal, so that we need a principle to explain how it gets tied down, as it were, to a particular thing, time, and place. For example, roundness can be instantiated in multiple objects at different times and spatial locations, and the geometrical truths pertaining to it remain true whether or not any particular round thing or a group of round things comes into existence or remains in existence. Roundness is thus not as such limited, so that something needs to be added to it if we do in fact find it limited in some way. Matter, the matter of this individual bowling ball, of that individual wheel, and so forth, is what does this job. For example, it is the matter of some individual wheel that accounts for the fact that roundness is instantiated in some particular automobile, is limited to that particular automobile, in a way that is not instantiated in, say, the tree next to the automobile or the road under it. Matter also accounts for limitation in another respect. The roundness of a circle, as defined in geometry, is perfect or exact roundness, yet any particular circle drawn on a chalkboard, in a book, or what have you, is always, at least to some extent, imperfect. Matter accounts for this kind of limitation too, insofar as, qua the potentiality to receive form, it is never fixed or locked onto any one particular form, but always ready to take on another. So matter has a kind of inner, you might say, readiness to go in some new direction, never locks onto one particular form. And that's why forms as instantiated in the material world are never perfectly instantiated, because the substrate is, you might say, of its nature, not the kind of thing that could lock on one rather than another. It's always got the potentiality to go in some new direction. Okay, it's like the kids in the back of the seat. Are we there yet? Are we there yet? You know, they want to get somewhere new, somewhere new. It doesn't want to hold on to a form, wants to go on to the next, right? For the moment, however, it's the argument from change about which more must be said. On an Aristotelian analysis, a real change involves the gain or loss of some attribute, but also the persistence of that which gains or loses the attribute. For example, when a banana goes from being green to being yellow, the greenness is lost and the yellowness is gained, but the banana itself persists. If there were no such persistence, we would not have a change to the banana, but rather the annihilation of a green banana and the creation of a new yellow one in its place. Matter, for hylomorphism, essentially just is that which not only limits form to a particular thing, time, and place, but also that which persists when an attribute is gained or lost. Now, it's absolutely crucial to understand that the characteristics of matter identified so far, its correspondence to potentiality as contrasted with forms, corresponds to actuality, its status as the principle of the limitation of form, and its status as the principle of persistence through change, are definitive of matter as hylomorphism understands it. That is to say, the hylomorphist is using the term matter in a technical sense. He is not saying that matter, as it has independently come to be understood in modern physics and chemistry, is what turns out to be the stuff that plays these roles of persisting through change, limiting form, and corresponding potentiality. He is so far not saying anything about matter in the modern sense at all. Rather, he is defining matter as that which plays these roles. That's what he means by matter, what it is that plays these particular roles. Nor is this some eccentric usage. In fact, it's an older usage than that familiar from modern physics and chemistry. Now, of course, how matter in this sense relates to matter in the modern sense is a good question, and it's one that I'll address presently. The point for the moment is simply to forestall irrelevant objections and misunderstandings. It's similar to say, well, I've studied physics and I never heard of all this limitation and change, so what are you talking about? Well, it would be a fallacy of equivocation. The hylomorphist is using the term in a specified technical sense, and as I say, I have yet to address how that relates to matter in the modern sense, but I will get to that a little later on. Now, one sort of change that takes place is change to a persisting substance. The subject of this sort of change is secondary matter. That is to say, matter already having a substantial form, matter that already amounts to a substance of some type or other. For the Aristotelian, we can identify three kinds of change falling into this class. There is, first of all, qualitative change, as when the banana in our example changes color from green to yellow. Second, there is quantitative change, as when the banana, having begun to rot, shrinks in size. Third, there is local motion or change with respect to location or place, as when the banana flies through the air when you toss it toward the wastebasket, or perhaps at a boring lecture or something. I want to give you any ideas. Another more radical kind of change is change of a substance, not change to a substance, but change of a substance, or a substantial change. It is change that involves not a substance gaining or losing some attribute while still persisting, but rather a substance going out of existence altogether and being replaced by a new one. This is what happens when the banana is eaten, digested, and incorporated into the flesh of the animal that ate it, or when it's burned and reduced to ash. Because change requires some underlying persisting subject that does not change, there must be such a subject in the case of substantial change, no less than in the case of the other, less radical kinds of change. But because it is the substance itself that goes out of existence in this case, it is a substantial form that is lost, not merely an accidental form. Hence, it is not any kind of secondary matter that is the subject of this sort of change, but rather prime matter. Now, since prime matter is that which underlies the loss of one substantial form and the gain of another, it does not of itself have a substantial form. It is therefore not any kind of substance. Nor, since the having of accidental forms and attributes in general presupposes being a substance, does it possess any attributes or accidental forms. Prime matter is not actually anything at all. But that does not entail that it is nothing. For remember that between actuality and nothingness or non-being, there is potentiality, which is a kind of being. That is what prime matter is, the pure potentiality to receive form and tie it down to a particular time, place, and object. Because potentiality cannot exist without actuality, prime matter does not exist without actuality. That is to say, it does not exist on its own, but only together with some substantial form or another. All matter as it exists in reality outside the mind is secondary matter. But that does not entail either that prime matter is not real, or that it is not really distinct from the substantial forms with which it is conjoined. Consider a parallel example. Being trilateral, that is to say having three straight sides, is a different geometrical feature from being triangular, having three angles, even though a closed plane figure cannot have the one without at the same time having the other. We can distinguish them in thought, and what we thereby distinguish are features that are different in reality, even if outside the mind, the one cannot be separated from the other. Similarly, prime matter and substantial form differ in reality, even if they cannot be separated in reality, but only in thought. This is a standard Thomistic metaphysical doctrine that a real distinction between two things does not entail that they're separable in reality. They might still be really distinct. Now, without prime matter, there can be no substantial change because there would be no subject of change that persists through the change. There would be rather the complete annihilation of one substance and the creation of another utterly novel substance in its place. That the world does not work like that is evident from the continuity that substantial change, no less than the other sorts of change, in fact exhibits. For example, wood that is burned reliably turns to ash, not to water or to cheese or to rose petals. Why would this be the case if there were absolutely nothing that carries over from the wood to the ash, but rather the complete disappearance of the first and the appearance out of nothing of the second? Why wouldn't just any old thing appear in place of the wood? Since that's not in fact what happens, there must be some principle of continuity, and that's another job that prime matter does. Okay, so that completes our look at hylomorphism, our exposition of hylomorphism. So we move on then to section 4, Roman numeral 4, on page 2 of your handout. In particular, this brings us to the mechanical philosophy, which is a generic label for a set of views about the nature of matter that began to supplant hylomorphism in the thinking of philosophers and scientists in the 17th century. The paradigmatic version is atomism, first developed by ancient Greek philosophers like Democritus and revived by early moderns like Pierre Gassendi and Thomas Hobbes. Atomism holds that all observable physical objects can be broken down into unobservable particles, which cannot in principle be broken down further. The idea of such an indivisible particle being the original meaning of the word atom. course, has in modern science come to have a different sense. Now we talk about splitting the atom. That would be a contradiction in terms for the ancient atomists, but that's because they're using the term in a different sense. Differences between observable objects, according to atomism, are just differences in the configurations of the atoms. And all changes to an object and changes of one object into another can be accounted for in terms of changes in the configurations of atoms as they move through space. Being indivisible, the atoms are the unchanging substrate of all change. Now, other versions of the mechanical philosophy have different conceptions of the particles. For example, Descartes thought that no particle could be indivisible in principle, so that there is no bottom level of particles, contrary to what the atomists hold. The corpuscularianism of Robert Boyle and John Locke agrees that all particles are divisible in principle, but nevertheless posits a bottom level of particles that simply happen to be undivided in fact. So that's a third way to spell out mechanical philosophy. A fourth would be the fourth shell atom theory of Roger Boscovich, which takes the particles to be unextended and thus indivisible points projecting shells of force. And there are yet other differences between these variations, such as their divergent accounts of the nature of space. What they have in common is the idea that all observable objects are really just aggregates of particles whose properties and powers can be reduced to the sum of those of the particles. It's something like the way that a machine is an aggregate of parts whose properties and powers can be reduced to the sum of the properties and powers of the parts. And that's the reason for the mechanical philosophy label, is this machine analogy, the idea that to understand a mechanism like a watch, for example, that was a favorite example, all you need to do is to understand how the behavior of the whole breaks down, can be broken down and reduced to the behavior of the parts. So the idea that we all reality is the components of which are the atoms. Okay, so in other words, the view essentially treats ordinary natural objects as having what hylomorphism would call merely accidental forms, rather than substantial forms. It also treats all the parts out of which they are composed, including the ultimate parts, as actual rather than merely potential. Everything's actual down to the bottom level, no potentiality. Once again, to refer to our water example, the mechanical philosophy would say that oxygen and hydrogen are actually, rather than merely virtually, in the water, and that its ultimate constituents are actual particles of some sort, rather than the pure potentiality of prime matter. All of this distinguishes it not only from hylomorphism, but also from Heraclitus' dynamic monism, since the mechanical philosophy takes the ultimate particles to be discrete and unchanging unities. Heraclitus denies that there are any such things. And mechanical philosophy is also distinct from the static monism of Parmenides and Zeno, since it affirms that the particles really are distinct and really do move through space. Of course, Parmenides and Zeno deny there are any distinct objects and that there is any change or motion. The mechanical philosophy would take Feynman's description of evaporation, which I quoted earlier, to be a paradigmatic illustration and indeed a vindication of the mechanical philosophy's mode of explanation. Now, the average educated person may even agree with that and suppose that the mechanical philosophy has been confirmed by modern science. But nothing could be further from the truth, or so I would argue. In fact, the mechanical philosophy's conception of matter faces a number of grave problems. For present purposes, I will discuss 5 of them. The first is what we might call the reductionism problem. Because the mechanical philosophy treats ordinary physical objects as having accidental rather than substantial forms, it entails that dogs, trees, stones, and the like are not really substances. The true substances are the fundamental particles. And to be a dog, a tree, or a stone is just for these particles to take on a certain kind of accidental form. A dog, a tree, or a stone is entirely reducible to the sum of the particles of which it is made. Just like, say, a little castle you might build on the wet sand of the beach is really reducible to nothing more than a configuration of the particles. Now, the problem is that it turns out to be extremely difficult at best, and indeed probably most today would agree impossible in principle, entirely to describe a dog, for example, in terms of nothing more than the particles that make it up and their properties and powers in conjunction. Dogs and the like simply have properties and causal powers that are irreducible to the sum of those of their parts. Now, many philosophers who acknowledge this opt for a position they call non-reductive physicalism. This is a standard view in contemporary analytic philosophy. That analytic philosophers would generally say, yeah, reductionism's dead, nobody believes that anymore. But we go for a non-reductive physicalism. It's still a kind of materialism. It's not Aristotle and it's not Descartes. It's materialism, it's physicalism, but of a non-reductive sort. The trouble with this, I would argue, though, is that this sort of view on analysis turns out to be ambiguous between hylomorphism and reductionism. As I've said, the irreducibility of a thing's properties and causal powers to those of its parts is, for hylomorphism, a mark of the presence of a substantial form rather than a merely accidental form. The non-reductive physicalist doesn't want to go so far as to revive the notion of substantial form and wants to treat the parts of a substance as actually rather than virtually in the substance. But this, the hylomorphist argues, implicitly entails reductionism after all, even if the so-called non-reductive physicalist doesn't realize it. For either it directly treats an object as having only an accidental form, and thus as not being a true substance after all, or it indirectly does so by virtue of denying the unicity of a substantial form. Okay, so this so-called non-reductive physicalism, I argue, is an inherently ambiguous position. On analysis, it either collapses back into reductionism, or it's really just a variant of hylomorphism without realizing it. It's really just a rediscovery of Aristotle without realizing that's what it's doing. Okay, so that's what I call the reductionism problem in a nutshell. And the second and related problem for the mechanical philosophy is what we might call the identification problem. If we say that a dog or a stone is really just a collection of particles, then we have to ask exactly which collection of particles that is. For example, does the collection of particles that make up the stone include those that are floating in the air 2 inches out from the surface of the stone? Does it include only those particles that exist half an inch or deeper below the surface of the stone? Well, presumably the answer in each case is no. But then it seems that we can identify the relevant particles only by reference to the stone of which they are the parts. We can't pick out the relevant particles except by reference to the stone as a whole, whereas the whole point of the mechanical philosophy was to show how there's nothing more to the whole than the particles. In this way, too, then, it turns out to be extremely difficult or impossible to reduce physical objects to collections of particles. We want to say, well, the stone is nothing more than a collection of particles. We want to ask, well, which collection exactly are you reducing it to? And there's no way to identify all and exactly those particles, not more, not fewer, except by reference to the whole stone of which they're parts. So the parts are really conceptually parasitic on the whole. A third problem is that from the point of view of hylomorphism, the atomist doesn't really get rid of substantial form and prime matter at all, but simply relocates them down to the bottom level of the atoms themselves. Call this the relocation problem. So suppose that to be a dog, a tree, or a stone really is to have a merely accidental form, that the only true substances are the fundamental particles themselves, the atoms, say, or corpuscles, whatever you want to call them. We would still have to regard them as composites of substantial form and prime matter, or so the hylomorphist would argue, for the reasons given in the arguments for limitation and change. For one thing, like any other form, the form of being a particle is universal. And so there must be something that ties that form down to some individual thing, time, and place. To this particular particle at this particular time and place, to that particular particle at that particular time and place, and so on. And that's the job that matter does, as conceived of in hylomorphism. And since the particles in question are fundamental rather than composites of something more fundamental, it's only prime matter that can do the job rather than any kind of secondary matter. And only this prime matter, together with the substantial form of a particle, would give us an actual substance. For another thing, as long as it is even in principle possible for a fundamental particle to come into existence or go out of existence, there will have to be something that underlies this substantial change, which brings us back to prime matter and substantial form, for the reasons I argued earlier. Now, of course, the ancient atomists held that the fundamental particles could be neither generated nor corrupted. But merely to assert this does not make it so. It's hard to see how there could be such particles. Any particle is going to be limited in various ways, to being of this particular size and shape, to being at this particular location at any moment, and so on. But what is limited in such ways is a mixture of actuality and potentiality rather than pure actuality. It is actually of this shape and merely potentially of some other shape, actually at this location and only potentially at that one, and so on. Now, only what is pure actuality, something which has no potentials that need to be, or indeed could be actualized, or which is, as it were, always already actual, only something like that could exist in a necessary way. Only something like that could be the sort of thing that can be neither generated nor corrupted the way that the atomists claim that the atoms are. The idea of pure actuality is, in fact, the philosophical core of the Aristotelian conception of God. Anything less than that could exist in only a contingent way. But then the fundamental particles would have to be contingent rather than necessary, unless they'd have to be the sorts of things which could, in principle, either exist or not exist. This capacity either to exist or fail to exist must have an underlying basis. And that brings us back to the conclusion that the particle is composed, after all, of prime matter in substantial form. Okay, so that third line of objection is essentially that even on the best case scenario, even if the atomists, in the form of the mechanical philosophy, could successfully show that the ordinary objects of our experience, dogs and cats and stones and trees and human bodies, are all really nothing more than aggregates of fundamental particles. And they only have accidental rather than substantial form. That would not eliminate substantial form and prime matter from our picture of the world at all. It would simply relocate it to the bottom level. It would be like the philosopher J.L. Austin talks about the frog at the bottom of the beer mug that's staring up at you when you get to the bottom. I guess this was a thing in England. He was writing. So prime matter and substantial form are like that. When you get to the bottom of the beer mug, as it were, the fundamental particles, whatever they turn out to be, they're going to be composites of prime matter and substantial form. And so you're still a hylomorphist after all. Okay, so that subject exists in it actually rather than virtually. For the parts in question are material parts that are extended in space. And anything extended is in principle capable of being divided into smaller extended parts. Now, if extended parts are divisible into smaller extended parts ad infinitum, and if all the extended parts are actually, rather than merely virtually, in physical objects, then it follows that every such object has an infinite number of parts. But in that case, the paradoxes identified by Zeno will follow. Every physical object would be infinitely large, and they would all be of the same size. Call this Zeno's problem. The idea is that the mechanical philosophy falls into exactly that problem. That is, you deny potentiality, you want to make matter actuality all the way through, you're opening the door to Zeno's problem, these paradox of parts. Now, it's sometimes claimed that the problem here is illusory on the grounds that infinite divisibility is merely an artifact of geometrical models and does not apply to concrete physical reality. But as the philosopher Thomas Holton points out in his book, The Architecture of Matter, this response misses the point. The paradoxes arise not from the geometry alone, but from the geometry combined with the premise that the parts of an object are all actual rather than potential. That's what poses the problem. That is why Aristotle can accept that a physical object is infinitely divisible without falling into Zeno's paradoxes, because he doesn't deny the mathematics, but rather simply rejects the assumption that the parts of an object are in it actually rather than potentially. The mechanical philosophy opens itself up back up to the paradoxes of Zeno precisely by taking on board that assumption, that is to say that all the parts are there actually rather than potentially. Okay, now that brings us to the fifth, final problem that I want to address for the mechanical philosophy, and that's the one posed by quantum mechanics. So that brings us to section 5, the last section of the paper. So as I say, let's turn finally to quantum mechanics, because that, I want to argue, poses this fifth problem for the mechanical philosophy and vindicates hylomorphism, or at least gestures back in its direction. To see how, recall first that hylomorphism takes prime matter on its own to be wholly indeterminate. By itself, it is not an actual particular physical thing of any kind, but rather the pure potentiality to be a particular physical thing of some kind. If we think of matter on the analogy of the position of a needle on a dial, and the values on the dial as representing the very specific kinds of material thing that might exist, prime matter is like a needle that is flitting wildly across the face of the dial. It has no intrinsic tendency to stop at any particular value, though potentially it could be made to stop at any of them. Substantial form is what actualizes that potential and makes of otherwise indeterminate prime matter a substance of some determinate kind, a molecule, a rock, a tree, a dog, or what have you. It's what stops the needle at a particular position on the dial. Now, if prime matter is like the needle flitting wildly across a dial's face, then for hylomorphism, a fundamental particle, considered in isolation and apart from any substance that it might partially constitute, is like a needle which has narrowed its flitting somewhat to a certain range of possible values. For example, fermions do not have the indeterminacy of prime matter, for they are matter of a certain kind, with properties and causal powers distinctive of that kind. However, they do maintain a very high degree of indeterminacy insofar as there is an extremely wide variety of more complex kinds of matter that they might constitute. They do not flit back and forth past every possible value on the dial, but they do still flit past most of them. A fermion qua fermion can be a constituent of water, of a stone, a dog, or what have you. Water and stone, by contrast, are like a needle that is settled down to flitting across only a very narrow range of possible values. Water may take a liquid, solid, or gaseous state. Stone may be arranged in a pile or used to construct a wall. Compared to a fundamental particle, though, there is relatively little transformation that they can undergo consistent with remaining what they are, namely water or stone. Whereas prime matter is the pure potentiality to be any material thing, fermions have a somewhat narrower range of potentiality, and water a much narrower range. Now, hylomorphism's treatment of the lower level material constituents of a thing as a kind of potentiality requiring actualization by higher level features is one of its essential differences with the mechanical philosophy, which treats all the material constituents of a thing as equally actual all the way down. And here, quantum mechanics is clearly closer to hylomorphism than it is to the mechanical philosophy. Indeed, the neo-Aristotelian character of quantum mechanics was recognized by Werner Heisenberg. Echoing the hylomorphic account of the relationship between prime matter and fundamental particles, Heisenberg writes in his book, Physics and Philosophy, quote, "All the elementary particles are made of the same substance, which we may call energy or universal matter. They are just different forms in which matter can appear. If we compare this situation with the Aristotelian concepts of matter and form, we can say that the matter of Aristotle, which is mere potentia, should be compared to our concept of energy, which gets into actuality by means of the form when the elementary particle is created," unquote. Regarding the statistical expectations that quantum theory associates with the behavior of an atom, Heisenberg says the following, quote, once again quoting from Physics and Philosophy, "One might perhaps call it an objective tendency or possibility, a potentia in the sense of Aristotelian philosophy. In fact, I believe that the language actually used by physicists when they speak about atomic events produces in their minds similar notions as the concept of potentia. So the physicists gradually become accustomed to considering the electronic orbits, etc., not as reality, but rather as a kind of potentia," unquote. And again, Heisenberg continues, quote, "The probability wave of Bohr, Kramer, Slater was a quantitative version of the old concept of potentia in Aristotelian philosophy. It introduced something standing in the middle between the idea of an event and the actual event, a strange kind of physical reality just in the middle between possibility and reality," unquote. To be sure, Heisenberg's way of expressing the point needs tidying up from an Aristotelian point of view. For one thing, he appears in these passages to contrast potentia with reality. But as I've said, for the Aristotelian, potentiality is itself a kind of reality, albeit one distinct from the reality that is actuality. Indeed, Heisenberg himself clearly agrees that potentia have a kind of reality. For elsewhere, he notes that they are, quote, "completely objective, do not depend on any observer," unquote. Heisenberg's identification of what he calls mere potentia, or pure potentiality with energy, also needs qualification. On the one hand, as the philosopher David Oderberg has suggested, if we think of energy as having no determinate form in itself, then one might be able to argue that it is identical to prime matter, though Oderberg himself refrains from endorsing that proposal. On the other hand, as another philosopher, Stanley Grove, has pointed out, energy is quantifiable, whereas prime matter, being wholly indeterminate, is not. In which case, energy would be a kind of secondary matter that, as Grove puts it, is, quote, "at least one structural level above that of prime matter," unquote. Now, yet another philosopher, Robert Kuhns, identifies several further respects in which quantum mechanics might be said to support an Aristotelian conception of matter, yielding a synthesis that Kuhns labels quantum hylomorphism. First of all, the Copenhagen interpretation treats microphysical phenomena, and in particular, the position and momentum of a particle as merely potential apart from interaction with macro-level systems, such as observers who measure the micro-level phenomena. Hence, like hylomorphism, the Copenhagen interpretation implies that the microphysical level is not metaphysically more fundamental than macro-level objects, nor sufficient by itself to ground all the facts about the macro level. Rather, the micro and macro levels are mutually interdependent, just as Aristotelianism claims. Second, there is the holism implied by quantum entanglement phenomena. The properties of a system of entangled particles are irreducible to the properties of the particles considered individually, or their spatial relations and relative velocity. The whole is more than the sum of its parts, just as it is in the hylomorphic account of physical substances. Third, quantum statistics treats elementary particles of the same kind as indiscernible, essentially fused within a larger system, thereby losing their individuality and merging into a kind of a quantum goo or gunk, as Kuhn puts it. As philosopher of physics Dean Rickles puts it, in quantum mechanics, such particles, quote, are really excitations of one and the same basic underlying field, and best thought of on the model of dollars in a checking account rather than coins in a piggy bank. They can be aggregated but not counted and distinguished, unquote. This echoes the Aristotelian position that parts exist in a substance virtually or potentially rather than actually. Now, Stanley Grove, to whom I alluded earlier, proposes that the wave-particle duality, famous from quantum interference phenomena, reflects precisely the greater indeterminacy that matter exhibits the closer it is to the level of prime matter. A photon can readily flit back and forth between wave-like and particle-like manifestations in a way that a cow cannot readily flit back and forth between cow-like and hamburger-like manifestations. Because particles being closer to the level of prime matter are, to use my analogy from earlier, like the needle on a dial flitting across a wide range of possible values. By contrast, a cow is far from the level of prime matter, insofar as there are several intermediate levels of kinds of physical substance between it and prime matter. For example, purely vegetative substances, middle-sized inorganic substances, particles of greater or lesser complexity, and so forth. A cow is like a needle that flits only across a very narrow range of possible values on the dial. Cheeseburger, belt, leather jacket. As Grove notes, the probabilistic nature of quantum events also reflects proximity to the level of prime matter. Again, the closer a substance is to the level of prime matter, the greater its indeterminacy, its tendency to flit across the dial, as it were, and thus the greater its unpredictability. Heisenberg's famous uncertainty principle is also, in Grove's view, something that should not be surprising on a hylomorphic conception of matter. A particle's momentum implies a potentiality toward a range of possible positions, and its position implies potentiality toward a range of possible momenta. But since momentum and position yield only potentialities rather than actualities, we should expect that knowledge of the one will yield less uncertainty vis-a-vis the other. Summing up the implications of the results of contemporary physics, the dispute between the mechanical philosophy and Aristotle, the late Stanford philosopher of science Patrick Suppies wrote the following, quote, "The empirical evidence from macroscopic bodies and also from high-energy particles is that the forms of matter continually change. There's no reason to think there is a spatial building up of electrons, for example, from some more elementary objects. The collisions of electrons and other particles to produce new particles, as observed, for example, in cloud chamber and other experiments, is simply good Aristotelian evidence of the change of form of matter. The cloud chamber data especially support Aristotle's definition of matter. As we observe change, there must be a substratum underlying that which is changing. What is the substratum underlying the conversion of particles into other particles, or the conversion of particles into energy? The answer seems to me clear." So he says, we can adopt an Aristotelian theory of matter as pure potentiality. Search for elementary particles that are simple and homogeneous, and that are the building blocks in some spatial sense of the remaining elements of the universe is a mistake, unquote. Some Thomist, and I think it was the late Ralph McInerney, but I've been unable to track down the quote, and I'm not sure, hopefully someone here can tell me, once remarked, "Whenever you've got a new idea, read Aristotle to find out what's wrong with it." Of course, that's an exaggeration. Some new ideas are good, but sometimes when they're good, it turns out they're not really new. Arguably, the example of quantum mechanics suggests another maxim. Whenever you've got a new idea, read Aristotle and find out if he already thought of it. Thank you.